72 seconds, the signal we never heard again. The night of August 15, 1977, Delaware, Ohio. A radio telescope the size of 3 football fields is listening to the sky. Nobody is in the room. The telescope runs itself. A computer prints numbers onto paper, hour after hour, and files them away. And at some point that night, for exactly 72 seconds, something pours into the receiver. A signal 30 times louder than the background of deep space. Then it stops. And in the 49 years since, no one, on any telescope, on any continent, has ever heard it again. This is beyond explanation, case number 1, the wow signal. But to understand what happened in those 72 seconds, you have to understand the machine that caught them. It was called Big Ear. Ohio State University built it in the late 1950s on farmland owned by Ohio Wesleyan University. It didn't look like a telescope. No dish, no dome. 2 giant metal reflectors facing each other across a field of aluminum-covered ground bigger than 3 football fields. And it couldn't move. Big Ear stared at one fixed strip of sky and let the Earth's rotation drag the heavens past its gaze. That one design choice matters more than anything else in this case. Remember it. In 1973, Ohio State pointed Big Ear at a new mission. Listen for artificial radio signals from other civilizations. It would run that search for 22 years, the longest continuous hunt for extraterrestrial intelligence ever conducted. The budget was almost nothing. The staff were mostly volunteers. One of them was an astronomer named Jerry Ehman. His job, take home stacks of computer printouts and scan the columns of numbers for anything unusual. For 4 years, nothing. Then, a few days after August 15, 1977, Ehman sat down with the latest stack. Page after page of 1s, 2s, blank spaces. The quiet hiss of an empty universe. And then, running down one column, he saw 6 characters that should not have been there. 6, E, Q, U, J. 5. He grabbed a red pen, he circled them, and in the margin he wrote one word. Wow. So what did those 6 characters actually mean? Big Ear's computer measured signal strength every 12 seconds and printed 1 character per reading, 0 through 9. Then, when the signal climbed past 9, letters. A meant 10, B meant 11, and so on up the alphabet. Almost every character on every page was a 1, a 2, or a blank. The static of space. 6EQUJ5 was a curve. The signal rose from 6 to 14 to 26 to 30. Then it fell away. 22 times stronger than almost anything else on the page. Here is the first thing that makes this case special. That rise and fall was not random. Remember Big Ear's fixed stare. Any true point in the sky, a star, a distant transmitter, takes exactly 72 seconds to drift across its beam. And as it drifts, the measured signal should rise smoothly to a peak at dead center, then fall smoothly away. The wow signal did exactly that. A textbook transit curve. An airplane doesn't do that. A grind transmitter bouncing off a satellite doesn't do that. The signal was moving with the sky itself. Which points to the second anomaly, the frequency. The signal came in at almost exactly 1420 megahertz. That number is famous. It's the hydrogen line, the natural hum of hydrogen atoms, the most common substance in the universe. Any civilization that builds a radio telescope discovers this frequency almost immediately. Which is why, back in 1959, 2 Cornell physicists proposed it as the obvious channel to use if you ever wanted another civilization to find your broadcast: a cosmic meeting frequency. And it's why the search teams at Big Ear were tuned to it. Now the third anomaly, and this is the one that quietly kills most easy explanations. 1420 MHz is a protected band. By international regulation, no transmitter on Earth is allowed to broadcast there. Not aircraft, not satellites, not radar. The band is legally reserved for radio astronomy, for listening only. So the signal was on the one frequency an alien civilization would deliberately choose, on a band where human transmitters are forbidden, moving in perfect lockstep with the rotation of the sky. It looked, in every measurable way, like exactly the thing the search was designed to find. There was just one problem, and it's the problem that has kept this case open for half a century. When something this strange shows up once, science has a procedure. You try to kill it. Explanation by explanation. Suspect 1, a satellite. Killed, mostly. No catalogued satellite was in that part of the sky broadcasting on a forbidden frequency, and a satellite crossing the fixed beam wouldn't reproduce that clean 72-second transit curve. Suspect 2, an aircraft. Killed. Planes move against the sky, not with it. The transit curve rules them out. Suspect 3, a ground signal reflected off space debris. Ehman himself favoured this idea for years. He did not want to overclaim. But the protected band, the frequency precision, and the transit shape make it a very awkward fit, and he eventually argued against his own suspicion. Suspect 4, the famous one, comets. In 2017, an astronomer named Antonio Paris proposed that 2 comets, 266P Christensen and 335P Gibbs, had drifted through that patch of sky in 1977, trailing clouds of hydrogen that could glow at 1420 MHz. Headlines declared the mystery solved. The radio astronomy community pushed back hard. Comet hydrogen clouds are far too faint. The comets, when checked, were not actually inside Big Ear's beam at the right moment. And a spread-out gas cloud cannot produce the sharp, narrow signal Big Ear recorded. Members of the original Big Ear team published a point-by-point rebuttal. The comet theory is dead. The headlines were wrong. Suspect 5, the most human explanation of all. A glitch. A one-off flutter in the electronics. Here's the problem with that. Big Ear had 2 receiving horns side by side. Every true sky signal should appear in one horn, then the other about 3 minutes apart. The WOW signal appeared in only one. And because of how the data was recorded, nobody can even say which one. Which means we know the signal came from one of 2 narrow strips of sky in the constellation Sagittarius, near a star group called Chi Sagittarii, but we will never know which strip. A glitch is possible, but a glitch that perfectly mimics a celestial transit curve on the hydrogen line in a protected band? That's not an explanation. That's a coincidence wearing a lab coat. So they did the only thing left. They looked again. Ehman and the Big Ear team repointed at that patch of sky more than 50 times. Nothing. In the 1990s, astronomer Robert Gray hunted it with the Very Large Array in New Mexico, an instrument vastly more sensitive than Big Ear. Nothing. He tried again from Tasmania, watching for weeks in case the signal was intermittent. Nothing. One detection, 72 seconds. And then 49 years of silence. For decades, that's where the file sat. And then, in 2024, it moved. A team led by astrophysicist Abel Mendez at the University of Puerto Rico went back through old data from the giant Arecibo telescope and found faint signals that looked eerily like miniature WOW signals. Same frequency neighbourhood, same narrowband character, far weaker. Their hypothesis? The Y signal may have been a rare natural flash. A cold cloud of interstellar hydrogen suddenly lit up, forced to blaze at the hydrogen line by a violent event behind it, something like a magnetar flare. A dying star's magnetic tantrum focused through a gas cloud, flashing a radio beacon across the galaxy for about a minute. It would explain the frequency. It would explain the strength. It would explain why it never repeated, because the alignment of source, cloud and Earth would be vanishingly rare. In 2025, the team sharpened the numbers. The signal was even stronger than anyone had calculated. So, case closed? No, and the lead investigator is the first to say so. In his own words, this study doesn't close the case, it reopens it. Because no one has found the magnetar, no one has caught a cloud doing this at full WOW strength. The hypothesis fits, but a hypothesis that fits is not a fact. And the alternative, that for 72 seconds in 1977 we overheard a transmitter we were never meant to catch twice, has never actually been ruled out. Here's what we can verify. On August 15, 1977, a real telescope recorded a real signal, 30 times louder than the background of space, on the one frequency the universe and its physicists agree is special, moving exactly as a celestial source should move. It was found by a careful man who never once claimed it was aliens. Jerry Ehman spent decades warning against drawing vast conclusions from what he called half-vast data. And here's what no one can tell you. What sent it? The one machine that heard it can never listen again. Ohio Wesleyan sold the land under Big Ear to developers in the early 1980s. In 1998, the telescope was torn down. Today, the place where humanity may have heard another civilization or watched a dead star ignite a cloud of hydrogen is a golf course. The printout survives. The red circle survives. The word survives. Wow. Status of Case 001. Unexplained. Some things refuse to be explained. We put AI on the case, and next week the case is a ship found sailing the Atlantic in perfect order, with every soul aboard gone. Case 002. The Mary Celeste. Subscribe. The files stay open.